The next special cases of binomials we'll be looking at are sum and difference of cubes, and we're going to look at those two cases at the same time because they follow the same pattern. The pattern for sum and difference of cubes is f cubed and then either plus or minus L cubed. And it's going to factor into the product of a binomial and a trinomial. So it will factor into a 2-term and then a 3-term factor. And they're going to follow the same pattern. The only difference is going to be the signs that you have within those binomial and trinomial pairs. It's going to factor into F and L, and then F squared, FL, and L squared. And the signs are going to depend on whether it's an addition or sum of cubes or subtraction, which is difference of cubes. But both times you're going to fill in the gap with SOAP. S-O-A-P. So the sign that goes in your binomial will be the same as the problem. The sign that goes in this first space for your trinomial will be the opposite sign of the problem. And the last sign will be always positive. So we have that same pattern that's going to repeat, and then we're going to fill in our gaps with SOAP. So for sum of cubes, the problem will start out f cubed plus L cubed, and when we factor that, it's going to be FL and then F squared, FL, and L squared, and we'll fill in those gaps with SOAP. So the first gap is S, same as the problem, so that will be addition. The second gap is O, opposite of the problem, so in this case subtraction. And the last gap is AP, or always positive. For difference of cubes, we've got the same process. F cubed minus L cubed is going to equal, we write out FL and then F squared, FL, and L squared. Fill in our gaps with SOAP. First one is S, same as our problem, so this time will be subtraction. Second gap is O, or opposite sign of the problem, positive this time. And the last gap is AP, always positive. Let's look at a couple of examples that will use this pattern of sum of cubes and difference of cubes. The first one we'll look at is 125x cubed plus 27. Again, we'll note that we're factoring a binomial, which is 2 terms. And the special patterns that we know are difference and sum of squares and difference and sum of cubes. So we're looking at the 2 terms, and we notice that they are both perfect cubes. We're still going to check for greatest common factor, and in this problem there is not one. And then we look at, we have a cube in the first spot and a cube in the second spot. So we're going to factor that by figuring out what the F term and what the L term are. So this time we have F times F times F is 125x cubed. So we've got to figure out what times itself 3 times would give us 125x cubed. Well, I know that 5 times 5 is 25, and then 25 times 5 again is 125. So F is going to be 5, and then x times x times x would give me the x cubed. So the F term will be 5x. Then I want to figure out what my L term is. Since I know that L times L times L is going to be 27, I can figure out that L is going to be 3 because 3 times 3 is 9, and times 3 again is 27. Now I've got to fill in my pattern. The pattern for sum of cubes is F cubed plus L cubed equals F and then L. Then we have F squared, FL in the middle, and L squared here. And then we fill in these gaps with soap. So same as the sign, positive, opposite sign, negative, always positive. So we're going to fill this in using F and L. F is 5x, L is 3. So it will be 5x plus 3 in the first parenthesis, and the second parenthesis is going to be f squared, so I have to take 5x times 5x plus, minus FL, so minus 5x times 3, and then plus L squared, so plus 3 times 3. When you work out these multiplication, you're going to end up with still 5x plus 3 in your first parenthesis, and the second parenthesis will be 25x squared minus 15x plus 9. And that's actually equal to the original problem. So if we were to FOIL that out, we would end up with 125x cubed plus 27. Our second example is going to be 500 x cubed minus 32. Let's check for greatest common factor. The greatest common factor here is going to be 4. So what I'm going to do is factor a 4 out, and that will leave 500 divided by 4 is 125, and we have x cubed minus 32 divided by 4 is 8. Now this problem now has a perfect cube minus a perfect cube, so we're going to be factoring it into difference of cubes. The difference of cubes formula will be f cubed minus L cubed equals, we start with f and L, and then in our second parentheses have f squared, FL, and L squared. Fill in the gaps with soap. So same sign as the problem, negative, opposite sign, positive, and then always positive. Then I want to identify what f and L are. Well, the space that has f cubed is 125x cubed. So I need to figure out what times itself will give me 125x cubed. Since we just had that in our last problem, we already know it's going to be 5x. Now for L cubed is 8. So we've got to figure out what times itself 3 times would give you 8. And that is going to be 2 times 2 times 2, so the L term is 2. And when we go back to our formula, we'll fill in all the F spots with a 5x and all the L spots with a 2. So this formula becomes 5x minus 2 times f squared, which is 5x times 5x, plus FL, which is 5x times 2, plus L squared, which is 2 times 2. So 500x cubed minus 32 is going to factor into 4 from our greatest common factor times the 5x minus 2 times the 5x times 5x, or 25x squared, plus 5x times 2, which is 10x, and then plus 4. And again, you can check all of your answers that you get from factoring by FOILing that product back out.